Hello, my name is Ashwin, and today we will be learning how to, well, it's an introduction to rational functions, so rational functions basically is a function, has a polynomial in it somewhere, like this one right here, and there's more specifics, but let's not get into that. We'll just start off with this division problem here, and here we have usually see a number like 12 and 3, and you get a 4 up here somehow. But this time we got a polynomial, and we have a x plus 2 here, which we have to use as the divisor. So there are two ways of doing this. First, you can do long division, just like how we do with big numbers. You can do it with polynomials too, and we'll start off with that. So what I'm going to do here is I'm going to start with this x plus 2 here, and I'm going to see x plus 2. So look at the x, and we have the x to the 4. And so we have to try to cancel that x to the 4, and we have to multiply from here to here, same way as we do in regular long division. And you should be able to easily see that x to the 3rd will go nicely in there, and that'll make x to the 4. I have to write really small. And 2x cubed. That's a 3. I need to conserve my space, so that's subtraction. And so these obviously cancel out, and we're left with so 3x cubed minus 2x cubed, that's an x cubed. Not to be confused with x at 3, right there. x3, I don't even know, it's 3x1, no, x cubed, okay. And then you bring the negative 7x down, just like you do with the number, how you bring numbers down in long division. And now, after I write this, I'm going to try to cancel out that x cubed, which should be pretty easy as well, and just multiply that by x squared, and you get x, second attempt, not bad, plus 2x squared. Now, what I think is the hardest part is making sure you get these signs right. A real headache, if you ask me. And minus negative 7x squared minus positive 2x, so that's actually minus 2x. So that'd be negative 9x squared, and I guess we don't really need the 0. And then we're off the line a little bit, but bring down the plus 20x, and now we have to try to get rid of that minus 9x squared, which also basic math, 9x at the top, okay, 9x, so we've got minus 9x squared minus 18x. This is where the signs might mess you up. You got the negative, subtraction, so these two will cancel out, and 20x minus negative 18x, so the minus minuses cancel out, so it's addition, so 38x, and then bring down the minus 17. I'm sorry, I don't even know if that's not even over. Minus 17, and then just gotta add on 38 there. 38x will cancel out. 38 will cancel out 38x. Please don't pull out your calculators for this. 38 times 2, you know, just 40 times 2, minus 2 times 2, that's positive 76. And once again, beware of signs. Minus 17, minus 76. If you really need to pull out your calculator, you shouldn't, but if you, I like to flip it over and think of it as 17 plus 76, and then flip the sign, so it would be minus 93, and this remainder here is important, because you can't just leave it at 93 and say you're done, because you can't just have a remainder of 93, because you're dividing, since you're dividing by, I mean, the remainder is 93, but you can append that onto here, same way you do with a, you know, regular long division. And so, plus, oh well, it's a negative, so there goes my, whatever, I don't even know, okay. And then we're dividing by that, so it's kind of like taking a, it's like taking a fraction, you know. And so, basically what this means is when you divide the big polynomial by x plus 2, you get that. If you multiply this, multiply the top part by x plus 2, you'll get the big polynomial. And it, you know, it doesn't factor because of this end remainder fraction thingy. And yeah. And so, but some of you may prefer that way. I kind of do, you know, like, I guess. I mean, it's more organized. You get to see where it's really, what's really happening. The other method that can be used, it's probably more popular, but you need to know this, the basics here to understand what is going on, and it's called synthetic division. And so we're just going to use the same one here to show you. I guess we should have saved what was up here, right? Ooh, fancy, okay. Let's just get all of that. So what synthetic division is basically an easier way to divide using just the coefficients and not having to worry about x's. You still gotta worry about the signs, which is really what I'm worried about, but maybe you don't like the x's, I don't know. Most people seem to not like the x's. So what I'm doing is I'm just gonna write these coefficients of the large polynomial in a line here, and I mean, you don't really need this line, but it's organized, I don't know. And what you're going to do is you're going to put a negative 2 out here because x plus 2, so what you have to plug in for x to get 0 is negative 2. So it's like when you're solving for zeros, like, you know, what the whole reason why you factor is to get the solutions. So this would be the solution, because we're leaving out the x's, so we have to flip the sign to make sure that we're still doing the same division problem. So we're going to bring down the 1, to start it off. And then we're going to multiply the 1 by the negative 2. So everything down here gets multiplied by here. So now we're going to put that here. We're just going to add that, and we're going to get 3 plus minus 2. So 3 minus 2, 1. And you can already start to see how, well, I'll explain it later, but okay, anyway. So then 2 and 1, so I'm going to have negative 2 times 1, negative 2 again. And when you add, you're adding, make sure you add, don't, I'm going to put additions on here, make sure you add, don't subtract. I guess it, okay. Yeah, make sure you add, so negative, I'm going to see if you can see the pattern. So negative 7 minus, plus minus 2, so negative 7 minus 2, negative 9. And then, now we're getting into some tough math here, where you're going to have to multiply negative 2 times negative 9. Negatives cancel, positive 18. I know, blows your mind. And 20 plus 18, 38. Hope you didn't need to use your calculator for that. And then negative 2 plus, negative 2 times 38. So negative 76, you did that calculation in the last problem. And then negative 17 minus plus minus 76, so negative 17 minus negative 76. Yeah, or like whatever. So anyway, and then you get a minus 93, and you can see how these are related. 1, coefficient of 1, 1, coefficient of 1, negative 9, negative 9, so on. So when you convert it, you're just going to do x cubed. That's like, 1. Just put that there to help you. 1 x squared minus 9x plus 38. And that's where you got to remember mutated 3. That's where you got to remember that you have to start off with the degree. This is actually the degree, like under the degree of this. So this is the x. This is the x to the 4. So you have to start with the x to the 3. So that, and if this ends up being 0 in a synthetic division, which in this case sadly it's not. I like it when it is because that means it factors. But if it's not, that means you got a remainder. So this number basically here is the remainder. So if you're 0, it factors with this value as a 0. Otherwise, it doesn't. And so if there is a number there, you're just gonna put it right there, and you're gonna divide it by the original expression, and you see in fact, not just similar, they are exactly the same, and that's why both of these work. I guess maybe you'd like synthetic because you're adding, not subtracting. I like subtracting and canceling out the negatives, and so yeah, that's how you find the result and the remainder from the quotient and divisor. So now we're going to move on to some functions, and first, and what we're talking about the functions is the end behaviors. And so we're going to start off with what is the end behavior of a rational function where the degree of the numerator is smaller than the degree of the denominator. And an example of that, so let's let's do something simple here. Yeah, so let's do x over x squared. Simple. Okay, we'll make it a function. Weird function. F of x should be on the other side, but function nonetheless. So this is, degree is smaller here because degree is 1 and degree is 2, so smaller, 1 less than 2. So what is the end behavior? And so what the end behavior is just a format where we say what happens as the function goes to its extremities on the x. When it goes to extremities on the x, what happens to the y value? And there's a pretty significant pattern. I guess we can put as. So, as x goes to positive infinity, what does y go to? And as x goes to negative infinity, what does y go to? Also, that's what we're trying to figure out. And if you just look at the graph of this, you can see that x over x squared, let's put in a value, let's say x is 1, so you get 1 over 1, 1. If you put in negative 1, you'll get negative 1 because negative 1 over 1. And then you get 2 and a half and a 2, and so on. You'll be able to see that looks something like that, excusing my drawing abilities while drawing on using an iPad on a computer screen. I'd say that's pretty good. Anyway, so we're looking and we can see that the x value is increasing, going to infinity this way, and as it is going, and of course a little hiccup right here, but it's really going down all the way, and it's not ever approaching 0. And, well, I mean, it's approaching 0, but it's never actually 0. But it's approaching 0. So we're just going to say that as x approaches infinity, y approaches 0. And looks to be the same thing the other way, even though, of course, once again, hiccup right here, but also it comes from the bottom and goes up, but we are still able to see okay, technical hiccup, calm down. I'm gonna keep talking. But okay, so as we're looking at the graph, where we can see that as x starts approaching negative infinity, going as it's going to negative infinity, the y is going to as y is also going to 0. That's what I'm trying to say, but I cannot show that because my internet is stupid, and there it is, right after we get out of the app. Alright, we're back. So, x going to negative infinity, y is going to 0, and there. So when the degree is smaller, y approaches 0 from both, as x approaches positive and negative infinity. Of course, that could change if you add a 1, then it'll approach 1 because you're just shifting everything up, But otherwise, that is it. So now we'll keep the general format of the end behavior format. That's what it should look like, and I'll erase that so I can write it better. So now we're looking at if the function has the same degree on both the top and the bottoms. For example, x squared, let's put some coefficients in here, 2x squared plus 3 and no, come back, alright, yeah, okay, and 5, let's say 5x squared plus 7, so degree is the same on both. It's a 2 equals 2, degrees are the same, and if we look at the graph, that's actually a pretty nice graph anyway. What you'll see is there will be a horizontal asymptote, but we're looking at the end behavior, so there will be asymptotes. And our asymptote, if we look at the graph, happens to be, curiously, I wonder why, right there, and we're just, that's y equals negative 2 over 5. And, not negative, why not put negative? I don't know, maybe I like negatives. Yeah. So, what is basically going on there is that, obviously, I hope you can see that the value that the asymptote is at is just the coefficient of the greatest degree on the top over the coefficient of the greatest degree on the bottom, and I guess I can point that out if you want. So it's just right, 2 over 5, plain and simple. And so what does that work every time? Yes it does. If you think about it in terms of like plugging values in and seeing what the result is, you can clearly see that I'm just going to draw this thing. You won't be able to tell what the exact graph is, but you'll be able to see, something like that, and keeps going down, that keeps approaching. So we'll approach 2 over 5. I like to call it A over B, if you will. I'll draw it in a general format. For that it's 2 over 5, but for reals, any expression, function like this, it's just going to be A over B, where it's A x y over B x y, and some junk on the end of these, but that doesn't all matter. And of course it can be shifted once again by stuff out here, like a 2, then it'll be 2 and 2/5, that's not 2, flag anyway, like that, not triangle, that's a 2, but yeah, A over B, so that's what the graph looks like, and if you start plugging values in, you can see at 0, it'd be like 3 over 7. At 1, it would be, what is that, 5 over 12, and then 7 over, not 7, okay, yeah, you know, it keeps going. It won't approach 0. You'll be able to see it approaching 2 over 5. If you're TI whatever's, you can look into the table and graph this and see. You might think it's approaching 0 at first, but you'll realize that if you look at it from the other way, if you look at it approaching, going this way, you'll see that it goes over the 0 line. I mean, it'll go over 0 and it'll approach 2 over 5. And so finally, we have the final possible scenario, which is what happens if the degree of the numerator is greater than the degree of the denominator. For example, x squared plus 1 over x plus 1. I'm just adding the I don't put plus 2. I'm just adding this plus 2 to show that these junk numbers show that it doesn't matter what's on the side. It's all about these numbers right here, the terms with the x's in it and the x squares. So we know it's this, and it's different for different ones. So if we're going to call them even, they call them even and odd. This is even because this part, the top part here, is even because x, like the degree of 2 is an even number. So this is odd because degree is 1 is odd. So if you're having an even odd like this, where it's even over odd, or odd over even, but the degree of the numerator is greater than the degree of the denominator. For this one, you'd see like a straight line, but if you say 3 and 2, or let's just say like 5 and 2, you'll see something like a cubic, because it's not a cubic, it's close, but something like that. So you'll see it approach negative infinity. As x approaches negative infinity, y approaches negative infinity, and as x approaches positive, y approaches positive. Of course, you could flip the whole function with the negative out in front, and the end behaviors would switch. So as x approaches infinity, y approaches negative infinity, vice versa. But basically, if you're looking at it like this, this is how it's gonna work. If it's odd, even, odd. Yeah, that's not my handwriting in classes, classwork, stuff like that. Anyway, so yeah. So if it's odd, even, odd, but the numerator has to be greater, not the numerator, the degree of the numerator has to be greater than the degree of the denominator, then yes, this is how it's going to work as far as end behavior. And you can just see that by plugging in. If you put in 2, you're going to get a decently big number. 3, it's going to be bigger because 3 to 5 is going to demolish 3 to 2 in any competition, except golf. Then, like 7, 8, 9, as you keep increasing the x, it's going to be an exponential, like really exponential change in the y. And same thing as you go negative, but this time it's just going to be flipped because the negative, so, But if that is not a, I'm not going to use that. That is not a, it's even, or odd, odd. So if the top and the bottom have the same, like even, odd, whatever, like, it doesn't even have to be, it's not the same number, but it's like 4 and 2, then this, whatever we have down here, is completely not what's going to happen. We'll see, basically, we're going to see some sort of, x squared, x of 4 function, where it's going to be plus infinity and plus infinity on both sides. And that's just because, x squared, the value you're going to get is always positive, unless, of course, you flip it, and then put negative out in front, then it's going to be negative, and y would approach negative infinity, and y would approach negative infinity for both of these. And you can, even if you put, like, 5 and 3, you will get, and even if you put in a negative, if you obviously put in a positive number, it's going to be approaching positive infinity, but even if you put a negative number in, you'll get negative over negative, cancel out, become positive, so you're still going to be going up like that. So this is the rule for if the numerator is greater than the denominator, the degree of the numerator is greater than the degree of the denominator. For odd, even, the graph looks something like this, and negative infinity here, positive infinity here, and this is how it would look if it's even, odd, odd, basically like an x squared function, and you'll see it approach the same infinity from both sides, if you will. And I believe that is it. Thank you for watching. I hope you're going to tune into my next one. It's going to be, hopefully by that time I'll have a Surface Pro. I'm going to be, drawing on an iPad with 3 fingers. And I'll be able to draw with a pen, but, $1,000 computers, parents, they don't go well together. But anyway, thanks for watching. Hope to see you again.